Hi everyone, today we are starting chapter 5. So 5.1 is midsegment theorem and coordinate proof. A midsegment. A midsegment of a triangle is a segment that connects the midpoints of the two sides of the triangle. So if we look at our example here, point D is the midpoint of AB, and point E is the midpoint of BC. Therefore, this segment DE is called the midsegment. And if I scroll down a little bit, this midsegment is parallel to this third side of the triangle, and it's also half of the length. So for example, if this was, AC was 10, it would mean that DE would have to be 5. It's half the length. So every triangle has 3 midsegments. So we have a midseg, since this is a midpoint, this is a midpoint, this is a midpoint, we have a midsegment here, here, and here. All right, so here's our first example. Segment MP is a midsegment of triangle LNO. Find the value of X. All right, so if I look here, MP is my midsegment. So we know from the previous slide that midsegments are half of the length of its parallel side. So if I draw lines here, I know that this third side is parallel to MP. So if ON is 16, what is half of 16? It's 8. So X would have to equal 8. For number 2, my midsegment is MP, and we know it's half of the length of the third side. So if MP is 7, X would have to be 14. Use the diagram of triangle XYZ where U, V, and W are midpoints of the sides. All right, so we know that U, V, and W are midpoints, so we then have 3 midsegments. So let's start with number 9. If UW is equal to 4x minus 1, so UW, I'm going to outline it, is equal to 4x minus 1, and YZ, which is this segment right here, and I'll do a little squiggle, is equal to 5x plus 4. We want to figure out what is the length of UW. All right, so let's think back to the midsegment. So we know that the midsegment is half of the length of the third side. So that means that UW is half of the length of YZ. Well, if I want to figure out how to make UW into YZ, I would have to double it, right? Because if UW is half of the length, if I double it, times it by 2, it's going to equal the entire length of YZ. So I'm going to write that out. So let's put 9 here so you know which question I'm talking about. So I'm going to double my midsegment, 4x minus 1, because if I do that, it's going to equal the longer side, 5x plus 4. All right, so if I double it, I need to multiply this 2 by everything inside the parenthesis, which gives me 8x minus 2 is equal to 5x plus 4. Now let's solve for x. I'm going to subtract 5x from each side, so that leaves this to be 3x minus 2 is equal to 6. Add 2 to each side. Hold on. Sorry, I was going too fast. So 3x minus 2 is equal to 4. Now add 2 to each side. So 3x is equal to 6. Divide by 3, we get x is equal to 2. But I'm not done because it asked me what is the length of UW. Well, we got to plug x back into my equation for UW, which is 4x minus 1. So that's 4 times 2 minus 1. 4 times 2 is 8, minus 1 is 7. So my answer is 7. All right, so for question number 10, and I'll write 10 here, it says, what's the length of YV? Well, if the shorter midsegment is 7, what would YZ be? Well, it would have to be double. So we know that it has to be 14, right? But let's double check to make sure that our math is correct. So if I have 5 times x, which we know is 2, plus 4, that is equal to 14, and we are correct. Coordinate proof. A coordinate proof is a style of proof that uses coordinate geometry and algebra. So we want to find the coordinates of the endpoints of each midsegment of triangle PQR. We're going to use the slope and the distance formula to verify that the midsegment theory is true for segment ST. All right, so we know that midsegments are created by finding the midpoint. So the first part of this is asking us to find the coordinate of the endpoints of each midsegment, which means we need to find the midpoints of each line. So S would be a midpoint of PQ. So what's the coordinate of S? It is 3, 3. T is the midpoint of QR, and the coordinate for T is 5, 1. And U is the midpoint of PR, and the coordinate for U is 2, 0. All right, so if I connect these midpoints, I then have 3 midsegments. So now the second part of this question is saying use slope and the distance formula to verify that the mid-segment theorem is true for ST. So let's look at ST, this midsegment. I'm going to start by finding the slope of this segment. All right, so ST, let's find the slope. And remember the slope formula. I'm going to put an M because M is slope. Remember, slope is rise over run. So if I start at S, and I'm going to use a different color here, I want to see, do I go up or down to go to T? Well, I would go down 2 and then over 2. So that is -2 over 2. Well, that simplifies. What is -2 divided by 2? It is -1. So I know that my slope of this segment here is -1. Well, if the slope of ST is -1, PR better also be -1 for their slope, because we know that these two lines are supposed to be parallel. Parallel lines have the same slope. So let's double check that. All right, so if I start from P, I go down and over. So that is down 1, 2, 3, 4. So -4 over 1, 2, 3, 4 over 4, which simplifies to -1. So those match up. So we're good so far. So we know that the slopes are the same. Now we need to figure out the distance. So remember, the mid-segment theorem states that ST should be half the length of PR. So let's double check to make sure that's correct. All right, so let's start with ST. And I know that the coordinate for S is 3, 3. So I'm going to call this X1, Y1. And T is 5, 1. So I'm going to call this X2, Y2. All right, so let's plug this right into our distance formula. And you should see here I wrote the distance formula up here for us. All right, so x1 is 3. I want to start with x2, sorry about that. So x2 is 5 minus x1, which is 3, and I'm going to square that, plus y2, which is 1, minus my y1, which is 3, and I'm going to square that. All right, so let's simplify this. So this gives me 2 squared plus negative 2 squared, which simplifies to the square root of 8. And if I plug the square root of 8 in my calculator, I get 2.828 approximately. All right, so now let's find the length of PR. And remember, it should be doubled, so let's see what that looks like. So for PR, I will call this x1, y1, this x2, y2. So this will give me 4 minus 0 squared plus negative 2 minus 2 squared. All right, so if I simplify this, that gives me 4 squared plus a negative 4 squared. And if I simplify that, it gives me 16 plus 16, which is the square root of 32. And if I plug the square root of 32 in my calculator, it is approximately 5.656, which is double what our segment ST was. So we just did the math. We proved the mid-segment theorem, stating that the mid-segment is parallel to the third side, and it also is half the length.